piecewise function today. So I just wrote the definition. It's rocket science, of course, but it's a function defined in pieces. So there's multiple pieces on the graph. There's not a specific number, like I don't have to have 2 pieces. I could have 2, we could have 3, we could have 4. Most of the graphs you're going to see in here are either going to have 2 or 3 pieces. And then you have to give the domain for which you're using those pieces. So what we're going to work on today, like I said, these graphs are already on the paper for you. What we're going to do is define them first, and then we'll do some evaluating real quick on the back. So all the pieces on the first 2 graphs we're going to look at are just linear. So there's equations of lines here. I have 3 pieces. A couple important parts of the graph here are going to be where the pieces switch. So let me try and grab a highlighter here. All right, so these are going to switch for different values of x. So the x goes from left to right as you go across the graph. And so what I'm going to do just real quick, I'm just going to kind of highlight those 2 vertical lines where the graph switches. Now, we have typically been using interval notation for the domain. We're going to use inequality notation for these piecewise functions. So I'm just going to write the domains real quick for you underneath the graph. Okay, so my first piece is on the left side of this x value, which this x value is just -3. At -3, I switch between the 2 different pieces. So this piece goes to the left. So I'm just going to write this on the graph so you guys can see it. So less than goes to the left. This is an open circle, so I don't actually touch that point. So this piece is for all the x values less than -3. Now, you don't have to write this. I'm going to just write it underneath. If I was doing the interval notation, it would be like -infinity to -3. And there would be a parenthesis there because I have an open circle. But we want to do the inequality notation. I just want to show you both real quick. Okay, the one in the middle, this piece is between 2 x values, that same one which was -3, and then I use this line all the way till I get to the x value of 1. So this is going to be a compound inequality. So I'm going to start with my smaller number on the far left. This is a closed circle, so I'm going to use, x is going to be in between here. X is going to be greater than or equal to -3. And then you have an open circle over here. So I'm going to switch again, but this will just be a plain less than, this is 1, which is the x value it switches over at. So between -3 and 1, we're going to use that second piece. If you want to think about the interval notation there, I would have a parenthesis and a bracket. We'd have a bracket for the -3 because that circle is filled in. And then I have an open circle here, so I'd have a 1 if you like that interval notation to kind of connect the 2. And then the last piece is just to the right forever after I get to the x value of 1. So to write that, this side, the x value, this is a filled in circle, greater than or equal to, this goes to the right forever. I know it goes up really quickly, but it goes to the right forever. X value is bigger than 1. If you wanted to do the interval there, I'm just going to do this on this first question so you could see. This would be a bracket at 1, and then the rest of that points to the right forever. So the interval notation would be that, but we're going to use inequality notation when we write these today. Okay, now that's the hardest part of the whole thing. The rest of this, you're literally just going to write me some equations of lines, which I know you can do. So in general, you've got y equals mx plus b. And I promise, I'm not going to give you anything crazy. You just have to figure out the slope and the y-intercept for each piece. So if I just look at the first piece to the far left, can you guys tell, just find 2 points that go right through a corner. Can you tell what the slope of that piece is? 2/3. Okay, should be going up 2 over 3. All right, so I'm going to write y equals 2/3 x. Okay, now, option 1, we can pick 2 points, use the slope, write the equation of line, blah, blah, blah. We're not going to do that because that's more work than we want to do. We want to do less work. Okay, easiest thing I can tell you to do, and I'm not going to give you anything weird. you might have to move it forward or you might have to back it up, but just figure out the b in that formula is the y-intercept. If I continued this, where would it cross the y-axis? All right, so if I just continued with my slope, like right here at this open circle, I'm just going to go up 1, 2, over 1, 2, 3, and then right there I'm on the y-axis. So I know that that line isn't being used that far over, but you can just continue that to figure out the y-intercept to help you write the equation. So it'd be 2/3 x minus 1. I'm just going to write it on the graph real quick and I'll write it to the side. Now, my favorite piece is a nice horizontal line. I like to call them horizontal line. Can anybody tell me the equation of that piece in the middle? It's just y equals 5. There's no, the slope is actually 0 there. So it's just whatever the y coordinate is, which is just going to be 5. All right, now the last piece, let's see. Can you guys tell what the slope is? 4 maybe? Looks like up 4 over 1. Okay, now in this case, if I want to find the y-intercept, I'm actually going to back it up. So I'm going to go down 1, 2, 3, 4 over 1, and that would cross at -8 if that actually touched the y-axis. So it's just 4x minus 8. To write the equation, I'm just going to come to the side here really quick. And what you want to do, this looks kind of weird, but it's not hard. I'm going to write f of x, or you can write y if you want to write y, equals. Okay, now there's 3 pieces. So this is kind of like if you guys have seen like a system of equations, like they'll have a big brace and it's just on one side, but we're just going to write down the 3 pieces. And I just did them in a color on my paper, so I'm going to use the same color. You don't write the y equals like I put on the graph there because you're already taking care of that out front here. So just start with the slope. So the first piece was 2/3 x minus 1. And then you just put a little comma, then you have to define the domain for which you're using that piece. So I'm just using that piece on the left side of -3 for my x value. So I'm just going to write that inequality that I wrote right under the graph. So this piece is being used for x values that are less than -3. And it's a plain less than because I got an open circle. Okay, the piece in the middle, and this looks kind of weird when you write it, but I don't want to write y equals. I've already taken care of that by putting that f of x out in front. So you literally just write 5. It's just the number 5. If you see a plain number, that's just going to mean on your graph you got a horizontal line. Now I'm using that between -3 and 1. That piece actually touches -3 where it meets the graph. And then it's got an open circle at the 1. So anytime you write a compound inequality, if you're writing it correctly, should be smaller number on the left, larger number on the right, and the arrows should both point to the left. And then the last piece was, let's see, 4x minus 8, and then just put a little comma. And I'm using that only to the right of 1. So my x values there for what I'm using that piece, greater than or equal to 1 because it starts with a filled in circle. It's not terrible. Is anybody having a question? Okay, let's try one more down here. Again, I would just, you're gonna maybe if you write the domain for yourself for each piece, that might help. And it's just gonna switch over. All the graphs I have today kind of switch over at the same point, but that is not something that is necessary. It doesn't have to switch over at the same point, but we'll have some graphs that do that in our next lesson. But these should all meet at the same domain values here. All right, so this guy's -2. So I got a filled in circle, less than goes to the left, so that's pointed to the left. So x is less than or equal to -2. That would be the domain for that piece. All the x values to the left of -2. Piece in the middle, we're between those two numbers, but I got 2 open circles. So -2 and x in the middle, and then that piece stops at 4. So between -2 and 4, we're going to use that second piece. And then the third piece switches over at 4, but that points to the right. So that third piece is going to be used for x values filled in circle that are greater than or equal to 4. That's the hardest part for people, is writing the domain. Usually if you write the equation line, it's not too bad. It's telling me where am I using that piece. Okay, let's look at the piece on the far left here. What do we think for our slope for this piece on the far left? Can you guys tell? What do you think? Well, that's not 2 over 3. What do you think? Rise over run. There you go, 3 over 2. Now, the only thing I would say to you here, like if I grab 2 points, try to go left to right. If you have to go down, then you know you got a negative slope. If you have to go up, then you got a positive. So this guy, your slope's going to be negative 3 over 2, and then I'll just put an X, and then we just continue the graph and figure out if it doesn't on the graph tell you where it crosses the y-axis, you're just going to figure it out. All right, so this guy looks like if I do this 1, 2, 3 over 1, 2, we're going to cross at negative 6. So just negative 6, that'll be that piece. Piece in the middle is super nice because I can actually see where it crosses the y-axis because it crosses the y-axis in between here. So just find your slope. This looks like rise over run, up 1 over 2, up 1 over 2. So just be 1/2 x, and then I can see on the graph that that crosses at negative 5. And any nice horizontal line is literally just y equals that number. So all those y coordinates are 6, and that would go to the right forever. So then I would just come over. And again, if you want to write a y equals or f of x, it does not matter to me. And then you just do that little like brace. Doesn't have to be perfect. Now, technically also you don't have to write these pieces in order as they appear on the graph. I usually just do that, but you just go ahead, just start with your slope. So the first piece, negative 3 over 2x minus 6. That's for all the x values to the left of negative 2. So I just write less than or equal to negative 2. That's because that circle was filled in. The middle piece is 1/2 x minus 5. And that guy is between negative 2 and 4. And those are both just plain x is greater than negative 2 but less than 4. So between those two open circles on both ends. And then a horizontal line, you're just going to see that appear as the y coordinate, which is just 6. And then that's going to the right forever, starting at x equals 4. So for all the x values greater than or equal to 4, we're just using that horizontal line at 6. Does anybody have any questions? Okay. Now on the back, this is why I had you guys practice those graphs on Friday, because they have a couple problems that they'll have like part of a parabola or part of a absolute value graph in them. And so that's what you guys are going to see on the back here. Now this graph actually has 2 pieces, and forgive me, this did not come out wonderful on the copy. This circle on the parabola here is supposed to be filled in. And then this one's open, that's a little bit more readable on the copy, but this is supposed to be filled in here. Otherwise, it doesn't pass the vertical line test if they're both open, and then it wouldn't be a function. Okay, I'm just going to have 2 pieces here. So one side of the graph, this is just to the left, so less than, this is switching over at negative 2. So this piece would just be plain less than negative 2. The other piece is a parabola, and it just goes to the right, and so it's going to be filled in circle there, greater than or equal to negative 2, where I'm going to use that piece, and I just have the 2. So we don't have a compound inequality when we're doing our description here. All right. Anybody feeling good about this? Could you tell me the y equals mx plus b for the first piece? What would you tell me the equation of the line is for that first piece? Oh, don't everyone volunteer at once. What do you think? What's the slope? Can you tell? So super close. It's not 4. Should be x plus 3. This is just going up 1 over 1, up 1 over 1. So it's just y equals just plain x, right? And then if you keep going, this would go up 1 over 1, up 1 over 1. This would cross at 3. So this piece is just x plus 3. Let me go ahead and come over here and write this just as we go. All right, so the first piece, just start with the slope, just x plus 3. That's for your x values less than or to the left of negative 2. Okay, now, we're not going to do anything weird here, but let me write you just a general form. I would recommend, let's just write vertex form. I don't need you to multiply it out and put it in standard form. For a parabola, you'd have a times x minus h squared plus k. That's just your plain vertex form, where hk is your vertex. And then the a value, you'd have to determine like kind of what the pattern of the graph is. Can anybody tell me the a value for the parabola we got on the graph right there? What do you think? It should just be 1. Yep, here's your vertex, right? You're going over 1, up 1, over 1, up 3. I know you can't see the over 1, up 5, but over 1, up 1, the a value is just going to be 1. The only other thing you need there is the vertex, which you can see on the graph. Here's the vertex of the parabola, and that is the point -1, +2. Now, when you plug that in, you're not going to see anybody write a 1 in front of the parentheses. They'll just start it with the parentheses, okay? Now, it would be minus a -1, so that's why I keep telling you guys it looks like the opposite. It would be x plus 1 squared. And then whatever the y-coordinate is, if it's negative, you write a minus. If it's positive, like it is here, you write a plus. And that would be what I would write for that parabola. So when I write that piece down, again, you just go ahead and start with the a value if you have one, or just go ahead and start out with the parentheses. This would be x plus 1 squared plus 2. And I got a filled in circle, so we're using that for the x values to the right of -2 or greater than or equal to -2. Is anybody having a question? I'm going to do one more with you real quick. That one involves an absolute value. This has 3 pieces. And I'm just going to, this is going to switch over at -5. And looks like +2. Okay. I'm just going to jot these down real quick while I've got the graph up on here. All right, so the first piece is filled in circle to the left of -5. So x less than or equal to -5. Absolute value is between two numbers. It's between -5 and 2. Both of these have open circles. So start with the smaller number on the left. So I'm going to do -5. I'm going to say x is greater than -5 but less than 2. And then the third piece is, sorry, some of these are a little hard to see, but this is just going to the right forever, but after you get to the x value of 2, and it's got a filled in circle. So greater than goes to the right, x is greater than or equal to 2 would be the interval that I'm going to use that third piece. Okie dokie. That is our slope here. And feel free to draw on the graph if you want to. Looks like our slope is -2, right? And this is kind of far away from the y-axis. I'm just going to continue that. Or if you want to grab 2 points and do it algebraically, you totally can. But I'm just going to go down 2 over 1, down 2 over 1. I promise I'm not going to give you anything that doesn't cross the y-axis in a nice spot. So if I just keep doing that all the way down, it should cross at -5. So to the side here, that first piece should just be -2x minus 5, and that's for the x values on the left side, or less than or equal to -5. All right, now, just so you have it on your paper, I'm going to write the general form for an absolute value. This would be y equals a times x minus h plus k, super similar. And a there, I'm going to put this in quotation marks, is basically the slope of either side there. If I'm looking at that absolute value graph on that piecewise function, what would you tell me a is for that? You're just going down 1 over 1, down 1 over 1 for each of these. So for this graph, the a value is just -1. So I would want to see a negative out in front of your absolute value symbols. And then you just got to grab the vertex. That's what goes in for h and k. So it looks like you have -2, 6 here. So if I plug that in, I would start a little negative, and then my absolute value, it'd be x minus a -2 or x plus 2. And then the k value is just 6. And then for my interval, we're using that for x values between -5 and 2. And then the last piece, zero, is my favorite because it's just a nice horizontal line. So you just tell me the y-coordinate of all those points, which should just be -1. And then we're using that to the right of x is 2 forever. So it's for all the x values greater than or equal to 2 since it starts out with a filled in circle. Okay, is anybody having a question? All right, now, I didn't give you any piecewise functions to evaluate, but I had you guys on that Math Excel assignment that we did on Friday. There were some that ask you to evaluate from a graph, so hopefully this will make a little bit more sense. We're going to go over this together, but basically, let me just make up I'm just going to make something up. So they will give you something like f of -1. Find my function at -1. Okay, here's what this means. Whatever is in the parentheses is what we would call your input or your x value. All right, what you want to do, find that x value on the graph and meet the graph. Like, find where x is -1 and meet the graph. And then the y-coordinate of that point is going to be your answer. So when they say, okay, I'm going to evaluate f of -1, just find where x is -1, meet the graph. You might go up, you might go down, it might be right on the x-axis. It depends on the point they give you. And then tell me the corresponding y-coordinate. That is going to be the answer to evaluate. It's like plugging a number into a function rule. I just don't have a function rule here. I've got a picture, so we're going to plug it into the picture. So if I come down here, this is the same exact graph that you guys had right above, but I just put it on here so we could see it on the screen. So like if I do f of -7, that's my x value. So just come over to -7, and then you're going to meet the graph. So find that point. So this is the point -7, 9. The actual answer to the question is just the output value, which is just the y-coordinate of the point. That's all you have to do. If I do -2, if I go over 2 to the left, meet the graph, it's actually just the vertex of that absolute value, so we already wrote that down, -2, 6, so 6 would be the output there. If I do 2, okay, this one's kind of tricky. If I come over to 2, I got two different options, right? Because I've got a point here and a point here, both on the x value of 2. Which one should I pick? Because? Exactly. You want to actually, it actually touches that point, it's filled in. So don't pick the open circle because you don't actually touch that point. So if I'm doing 2, I got to go to this point, which would have the y-coordinate of -1. So if you have like a competition basically between two, stop throwing stuff at me. If you got a competition between the two, pick the closed circle, not the open circle. There's only one correct answer there. All right, so same thing. If I do -5, right, there's a competition between the two. We don't want the open circle because I don't actually touch that point. So if I'm at -5, we're going to be up at +5 as our answer. All right, let's see what else. So I've got 0. Looks like right here. So that's the point 0, 4. So if we plug in 0, our output there is 4. And then the last one I have is 5. So over here at 5, just go down to meet the graph. That has the point 5, -1. So the -1 would be the output. Is anybody having a question? If you guys want to get out that set of graphs that we did on Friday so I can come get those